Hello everyone, this is Mr. McMillan and I'm back with another instructional video, this time on writing proofs for the triangle congruence postulates and theorems. Okay, so this is going to be just kind of an addendum. It's just something that I want you to be aware of. So if you do see it somewhere, you know how to do it. Okay, this has shown up before, but it may be on a quiz or a test in the future, but for the most part, this is to help you think. Okay, so in the past few lessons, we have discussed how to analyze given information and diagrams to make conclusions regarding triangle congruence. We discussed 5 postulates and theorems that could be used to prove 2 triangles are congruent. Today, we will be discussing how to formally state our conclusions in a proof which is given in a 2-column format. Okay, so a proof. So we're looking to prove things in this lesson. So a proof is a convincing argument that shows why a statement is true. So just like in real life, when you have to prove a statement is true, you need to give some type of explanations and reasons for your statements, right? You can't just say things and assume them to be true. You have to have evidence. That's the whole entire point. You have to have evidence. These have numbered statements that show the logical order of the argument written as a 2-column proof. Okay, so you're going to have 1 column be your statements and 1 column be your reasons. Usually the statements go on the left and the reasons go on the right. So how do we write a 2-column proof? Well, before beginning to write a proof, make sure to examine and analyze the problem for any given information. Given information in a problem is stated or shown in the diagram. Note that given information does not include shared sides or vertical angles. These pieces are stated using properties, and we'll talk about that here in a bit. Let's look at the steps below. So our first step here is we want to list any given information that is given to us first. That's the stuff we're going to list first. We're always going to list our given information. And this is similar to when I ask you guys to look at a problem and you say, hey, or I say, hey, what is the information that's given to you in the problem? That's always the first thing that I ask you guys. Okay, so this could be stated information in a problem. So for example, line segment CD is congruent to line segment AB, angle E is congruent to angle F, etc. Or information that's already marked in a diagram. And remember, you use tick marks, parallel lines, right angles, anything like that. Next up, you're going to use information from the diagram. So for instance, you might have some shared sides, okay? Or you might have some vertical angles. That'll be the next things you state. They're not going to be given to you, and they do have a reason for those. And the reason that we use for these, and we'll talk about it in more detail here in a second, we use reflexive property for shared sides. And technically, we use reflexive property of congruence. And it's like looking in a mirror, okay? So reflexive, reflect. If you look in a mirror, it's the same person looking back at you, right? If it's not, you should be terrified, okay? So if it's not you looking back in a mirror, it's not reflexive. And then, of course, vertical angles, will always use the vertical angle theorem. They are always congruent. Okay. Next up, you're going to want to give a reason for every statement. Information is listed in the first column, so the one that's on the left. Reasons are listed in the second column, which is on the right. Reasons may include given information, definitions, postulates, theorems, and properties. Number 4, we're going to list our statements in order. If a statement relies on another statement, list it later than the statement it relies on. Okay? So in other words, it's just a logical flow of thought. Okay? You don't walk before you crawl, right? But I don't know of many, if any, babies that walk before they crawl. So, you know, it would logically be saying you have to crawl before you can walk. And then you walk before you can run, and so on and so forth. Number 5, we have to end the proof with the statement we are looking to prove. Okay. So that might be that two sides are congruent. It might be that two angles are congruent. It might be the triangles are congruent. Either way, we're looking for, or we will end the proof with a statement we are looking to prove. So common reasons used in proofs regarding triangle congruence, and we'll talk about this as we go along in the example proofs. So given, this reason is used for any information that is given in the problem or diagram. So if something is explicitly stated or marked in the diagram, you'll list out what it says in the diagram, and then you'll write given in your reason. And you can write either given or given in diagram or problem or whatever, as long as you have the word given there. Next up, the reflexive property of congruence. This is any geometric object being congruent to itself, okay? Any angle is congruent to itself. Any side is congruent to itself. So for example, this would apply to shared sides. For example, line segment RS is congruent to line segment SR. Those would be the same line. Even though it's different orders, they would still be the same object, so they would be congruent. Next up, vertical angle theorem. This is used when two angles are vertical. And remember, vertical angle theorem means that the angles are congruent. Next up, this one's used a bit less frequently. We don't really use it, but just want you to know that it exists. The transitive property of congruence. This is similar to the transitive property of equality. So it states if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. This works for any geometric object. Next up, special angle pair theorems. So you may see parallel lines and special angles in the diagram. So remember, that could include alternate interior angles, alternate exterior, same side interior, so on and so forth. We'll be looking at some of those today. Triangle congruence postulates and theorems. This will be our most used thing at the last bit. We're normally looking to see or to prove that they're congruent somehow. And this will be the last statement and reason that we do. Okay, so remember that includes side, 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 side angle side, hypotenuse leg, so on and so forth. Next up, definition of blank triangle. Any triangle name can go here, isosceles, equilateral, right, anything like that. So based on the diagram, you may be able to conclude something based on the type of triangle with this reason. So for instance, you might be able, if you see a right angle in your diagram, you can conclude that there is a right triangle there by definition of a right triangle, because a right triangle has one right angle. Then finally, you might see definition of and then a generic statement here. Objects interact with one another in geometry to form other statements. You may see midpoints, perpendicular and parallel lines, etc. Pay attention to what is stated in the problem, okay? So you need to make sure you pay attention to that. So let's look at some examples, okay? These first few examples that we're going to do, we're going to write the entire proof. The last few we're going to fill in with what they gave us. And the first few are simpler, that's why I'm having us do it all. And it helps line our thoughts up as well. So let's look at number 1. It says given figure QRST with diagonal RT, QR is congruent to ST, and QT is congruent to SR. It wants us to prove that triangle QRT is congruent to triangle STR. So what you need to do is figure out what parts are relevant for your situation. Now here, it just gives us that figure QRST has a diagonal RT. That's not too relevant, it's just describing this figure. Okay, so we don't actually have to list that at all. We're trying to prove triangle congruence. This is the statement we're trying to prove, so we're going to go ahead and write this in our statement. QRT is congruent to triangle STR. We'll have to figure out the postulate for why that is, but that's what we are looking to prove, so that's our last statement. So remember, our first step, we want to list the given information first. So let's see what information the problem gives us. So we see that given, and it says QR is congruent to ST. So I'm going to go ahead and mark those on the diagram as well, just to give me a visual indication. And then I'm going to write QR is congruent to ST. And then in my reason, since this was given to me in the problem, I'm going to write given as the reason. Well, is there any other given information in the problem? Yes, we should see that QT is congruent to SR as well. So we're going to put our congruence symbols there. We're going to write that in as our next statement. And we're also going to say this is given as a reason because it is given to us. Now, next thing you look for is any other given information. Well, we don't have any other information that's given to us in the problem. But let's look at our diagram. Can we figure something out? Remember, our second step wants us to look for any shared sides or vertical angles. So do you see any shared sides or vertical angles here? Well, you should see that there's a shared side right here. So a shared side right there. Well, RT is congruent to itself. RT is congruent to RT. Now, if you remember, we'll flip back real quick. This would be the reflexive property because you are basically looking in a mirror. Any geometric object is congruent to itself, okay? So that would be our reason here that we would write. We would write reflexive property of congruence. And if we look at our diagram, we should see we have 3 pieces of information given to us, or 3 pieces of information we figured out, so that's enough. So if we label our, what we've labeled up here just to help us identify, we see that we have 3 pairs of congruent sides. So that means we have the side, 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 or SSS, congruence postulate as our last reason. Okay, so this is a formally stated proof. Now you might be going, well, I could have figured that out easily, and you're right. But what this purpose, the purpose of writing proofs is that you are showing your logical thought and your arguments. So it's basically showing your work, but for reasoning purposes instead of solving an equation or something of the sort. Okay, so let's look at number 2. And if you want to, you can try it on your own, you know, and come back to the video, or, you know, or not. So it says given angle R is congruent to angle G, angle N is congruent to angle P, and side or line segment RN is congruent to line segment GP. Prove triangle ARN is congruent to triangle KGP. All right, so again, our first step is going to be looking at what is given in the problems. So if we look here, we're given that angle R is congruent to angle G. We're going to go ahead and write that in and mark it on our diagram here. And our reason for that is given. Next up, we're given angle N is congruent to angle P. Mark that. As given. And then we're given Rn is congruent to GP. And this is also given. So we want to prove the triangle ARN is congruent to triangle KGP. And if we look here, we'll label our diagram with what we have here. We have two pairs of congruent angles and one pair of congruent sides. And we see that the sides are between the two angles, which means that we're using angle, side, angle, or ASA congruence postulate. Okay. All right, next up, number 3. Given line segment DH is parallel to line segment LM, line segment DH is congruent to line segment LM, and line segment ZH is congruent to line segment HM, prove triangle DHZ is congruent to triangle LMH. So we're trying to prove this is true, so this will be our last statement. And again, what we want to do is figure out what our given information is in the diagram or the problem, list those first, and then see what else we can list. So first off, it gives us that DH is parallel to LM. And this is given. Then it gives us that DH is congruent to LM. And that's given. And then ZH is congruent to HM. Which is also given. Now, as you know, we need two pieces, or we need one more piece of information because we're only given two congruent sides here. Okay, so we need something else here. So let's see if we can figure out anything from our diagram. Now, if we look here, we have two parallel lines. And we see that LH acts as a transversal. Now, since LH acts as a transversal, we're going to cover this up here. We can tell from our diagram that angle M here is congruent to angle H, or angle DHZ. Now, the reason for that, if you look at these two parallel lines here and you look here, this is inside and this is also inside, okay? You can also use this as the transversal as well, okay? But you can see that these two angles would be corresponding angles. So this is the corresponding angles postulate. So that means we have two congruent pair of sides as well as one congruent pair of angles. So this is side, angle, side, or SAS, congruence, postulate. Number 4, we want to use the information in the diagram below to write an appropriate proof to show triangle DCE is congruent to triangle WCG. Okay, so that's going to be what we're proving. So that's going to be our last statement here. And let's see what we have. We don't have anything stated in the problem that we want to do, or anything that we're given anyway. But so let's look at our diagram here. So if you look, we have some triangles on the diagram. So that means that these two line segments are parallel. So BE is congruent, or not congruent, is parallel to WG. This is given in the diagram. We also see that both BE and WG have a congruency mark. They have one congruency mark each, so that means that BE is congruent to WG, given in the diagram. Now the next thing we need to look for is any shared sides or vertical angles, and you should see here that these two angles are vertical angles. So that angle is angle BCE, being congruent to angle WCG. And this is the vertical angles theorem. All right. Then we still need something else here. We have a side and one angle. Okay, we have one pair of sides, one pair of angles. So we need something else. So anytime that you are given parallel lines, you probably want to start looking for some congruent angles. Okay, so let's look here. Let's see what types we have here. We have this parallel line here and this parallel line here. There are two different transversals here. Okay, I'm going to use these two, or this transversal here. Okay, now let's look here. If you have this transversal, which two angles are attached to that transversal? Well, we see that E is attached and G is attached. What type of angles are E and G in this case? Well, if you go through here and look here, they are both inside of the parallel lines, so we know they're interior, and they would be on opposite sides of the transversal. So that means that these two angles are congruent. By the alternate interior angles theorem. If we look here, we have two pairs of angles. We also have one pair of sides, and we can see that the sides are not between the two angles. So this would be angle, side, or AAS congruence theorem. Now I do want to point out, you could also have used this transversal and concluded that angle B and angle W would be congruent by this instead. This would mean, so if we'd use that statement instead of this statement, this would mean we would use ASA instead of AAS. Okay. And for most of these, you're not going to be writing out a full, if you have this question on a quiz or a test or anything like that, you're not going to be writing out a full proof. You're going to be dragging and dropping or selecting reasons that need to go in certain blanks. Okay. All right, let's look at number 5. So this is more akin to what you would see on a quiz or a test. You're given some information and you need to fill in the blanks for the reasons. So it wants us in number 5 to write a 2-column proof that shows triangle JKL is congruent to triangle NML, given that JL is congruent to NL and L is the midpoint of KM. So the first thing we're going to see is if we have any given information, and that's what our first 2 reasons are. So there are 2 things that say given here. So we're given 2 pieces of information. JL is congruent to NL, and this is already marked in the diagram. The other thing that we're given is L is the midpoint of KM. Okay. Next up, it says the angle JLK is congruent to triangle or angle NLM. So these 2 angles are congruent. Now we need to figure out the reason those 2 angles are congruent. Well, if we look at those 2 angles, we should notice they're what type of angles? That's right, they're vertical angles. So this would be the vertical angles theorem. All right, then the next one, it says the reason is the definition of midpoint. So again, if L is the midpoint of KM, remember that the midpoint means it's the center point. The midpoint splits a segment into 2 congruent segments. So if L is the midpoint of KM, that means that KL is congruent to ML by that reason. So that's the definition of midpoint, that KL would be congruent to ML. So do we have enough information to prove this? Yes, we do. We have 2 pairs of sides, 1 pair of angles. The angles are between the 2 sides, so we can use the side angle side SAS congruence postulate to prove that triangle JKL is congruent to triangle NML. Okay. So see what you can do with number 6. See what you can do with number 6. All right, so let's look at number 6. It says a step in a game creates the triangle shown. Prove that triangle ABD is congruent to triangle EBC. So again, we're trying to prove this is true, so we are going to write that down in our final spot. So let's look at what our statements and reasons are already given to us. So we see here that it says BD is congruent to BC, and it wants a reason that we know that. Well, if you look here in the diagram, you see that we have congruency marks on them. So we would write that this is given in the diagram. Number 2, it says that line segment AD is parallel to line segment EC. And if we look here, we can see that there are triangles on there, which means they are parallel. So this is given in the diagram as well. Next up, it says angle D is congruent to angle C. Now you'll notice that it doesn't have any congruency markings there. So you need to make sure you understand why these are congruent. Well, again, we have parallel lines here. And then D and C are attached to this transversal here. So I'm just extending everything out here. So if you look here, D is congruent to C, and we have to figure out the reason. Well, what type of angles are D and C? Well, they are inside of the two parallel lines, and they are on opposite sides of the transversal. So that means that these are alternate interior angles. Alternate interior angles theorem. And that's why they're congruent. Note that you could also say that angle A is congruent to angle E, but this one wanted us to use angle D is congruent to angle C. Next line, it says our vertical angles theorem. So what are the names of the vertical angles here? Well, we see we have these two angles are vertical. The first one has the name angle ABD is congruent to angle, and then we have angle EBC. So now we want to show that this is these are congruent. We have enough information. We have two pairs of angles given to us, as well as a pair of sides. The sides are between the two angles because they touch both of the angles. So that means we have the angle, side, angle, or ASA, congruence, postulate. Okay, so that's what these proofs are. All right, we're going to look at two more here, number 7 and number 8. We want to use the diagram in number 7 to prove that triangle PRQ is congruent to triangle PRS, given that PR is perpendicular to QS and PQ is congruent to PS. So let's look here. Our first statement here says PR is perpendicular to QS, and that was given to us in the problem. Next, it says that angle PRQ and angle PRS are right angles. Well, the reason that angle PRQ and angle PRS are right angles is because PR is parallel or perpendicular to QS. So this would be the definition of perpendicular lines. Next, it says definition of a right triangle. Well, if a triangle has a right angle, then it is by definition a right triangle. So triangle PRQ and triangle PRS are right triangles. Then it says PQ is congruent to PS. Well, it gives us that in the problem and the diagram. So this is given. Then it says PR is congruent to PR. Remember, this is like looking in a mirror. And if you look in a mirror, it's the same person. It's your reflection. This is the reflexive property of congruence. Then the problem wanted us to show for our final statement here, it wanted us to show that triangle PRQ is congruent to triangle PRS. So now let's look and see what information we're given. We have two right triangles. We have a pair of congruent hypotenuses and a pair of congruent legs. So this is the hypotenuse leg HL congruence theorem. Then let's look at number 8, our final example here. This one we're going to write the entire proof. Use the information in the diagram to prove that triangle WVY is congruent to triangle XZW. So that's going to go in our last statement. Triangle WVY is congruent to triangle XZW. let's see what we have in our problem here. We have some markings here. First off, we're going to notice these angle congruency marks, and we see that angle X is congruent to angle YWV, and this is given in the diagram. Next up, it gives us that XW is congruent to YW. That's given in the diagram. So we have a side and an angle given to us so far. So we need one other piece of information. Well, next up it says that, that we see the two triangles here, so we know that these two lines are parallel. So YV is parallel to WZ. And this is given in the diagram as well. So we need to still find one piece of information. Well, remember, these are parallel lines. So it means we're looking at transversals here. We're going to say that this is our transversal because it's the only one that makes sense. And if we look here, we can see the angle Y and W here, or XWZ, would be congruent because they are corresponding angles. One's in the interior, one's in the exterior, and they're on the same side of the transversal. So that means that angle Y is congruent to angle XWZ. And that's because of the corresponding angle postulate. So with our given information, we have two pairs of congruent angles, one pair of congruent sides, and that the sides are between the two angles. So that means we're dealing with angle, side angle, ASA, congruence postulate. And that does it for this video, guys. This is just a video to make sure that you have access to something that may show up on a quiz or a test or anything like that, or an SOL. So make sure that you review this video fully. If you have any questions, please email me and let me know, or join the Zoom sessions where I can help you out during live instruction. Thanks, guys, and I will see you in the next video.